Hi friends, in this video the students are going to explain about the inheritance case study for the vehicle management system for the course books using Java.
So, hello everyone. Today we are going to discuss about the vehicle management system as ma'am told in terms of case study, because it is important to analyze the problem and also the solution and how effective it is working. So, to start with, we have analyzed the first problems which the fleet managers and also the software users have faced, and it comes like there are very many types of vehicles like car, bus, truck or bikes or even etc. There may be many types of vehicles, but the thing is they have some specific features and also common features. Common features may include like models, vehicle number, the pollution status of it, and specific things may include like for a car specifically there will be a door type, door model or the specifications of that. If in case of two-wheelers like bikes, we have the handlebar sizes and adjustment specifications. So these are all the data which they have in their management system. So the main problem that they face is that first thing is they are facing difficulty in uploading new data and also manipulating, changing the data to the new status from the old status, and also having a complex organization method because there are many types of vehicles, many specifications and many features also which we go through daily in the day-to-day basis. So analyzing all this, the main problem statement which we have is that there should be something like an advanced management system which can be used in terms of to easily maintain and manipulate the data. And the next thing is complex and easy status to update the value and add new value for all the types of vehicles. And second thing and most main thing is that we should reduce the size of code or the number of lines of code and also erase duplications. So all these should be analyzed and come to a great solution. So for that we have come to an idea which will be explained by Bharat.
So after analyzing the problem statement, we have come to a conclusion or an idea about how we can classify the vehicles. So basically, vehicles have many features like the fuel types, the models, brand, etc. So from that, we can we can basically divide the project module into two types. One module consists of a base class that defines the models and the common features of every vehicles, and the second type is child class that can divide each vehicle into different categories like cars, bikes, trucks, etc. So the base class basically contains the common features like the fuel types, the brand, the models, and much more features like the start method of an engine and the start engine and stop engine kind of functions methods. And the child class would contain certain specific features of each vehicle. Like for example, for cars, we can consider the type of doors. Some cars may have 2 doors, some cars may have 4, and some may have even some type of cars may have 6 in like limousine. So so it's a perfect example for a feature, and I can also have another feature like air conditioning. Few older cars may have does not have air conditioning, but the newer cars that can come today would have air conditioning, and the type very different. And for bikes, we can basically divide it into race bike based on CC, the power of the vehicle, and also we can differ it by the aerodynamic features, simply the sports bike, etc. And for trucks, we can divide it based on the axles, number of tires, wheels it have, and the number of weighing capacity it can hold. So this is the idea we can derive from the problem statement. And next, that's it. May continue.
The vehicle management system of a prototype to create a parent class in vehicle, then the children class as bike, car, truck, and they each class as vehicle children node inheritance method keyword in OOPS. They have shape and classic colors like etc. So we create an object from each class and call them to access a start engine function. Next we'll continue by Achilles testing.
So the testing results of the vehicle management system. So adding new vehicles like car, bike, trucks, etc. So because of that, we want to create the base class and test the base class. So we like the start engine and stop engine. So we want to also check the unique attribute of the each vehicles. So the second mainly the updated vehicle details like their fuel types, brand, like fuel type maybe petrol, diesel, etc. So okay, then we want to test there the all manual thing to automatically. So any manual features are not included in that, and only the vehicle is in automatical mode. So extending with a new type like a electrical vehicles. So it includes a fuel type that is electric. So want to check the capacities like battery capacities and fuel types like and unique. These are the unique attributes that from the other vehicles. So and we want to include the edge cases like load capacity of that vehicles and like that. So the overall conclusion of this project will be saved by everything.
And before that, I want to mention that by using inheritance, there are a number of codes and number of codes is reduced and reusability of the code is involved in this. Because of that, we have effective utilization of your program. So we can conclude with that.
Yes, ma'am. So as everyone told, as ma'am also mentioned, we could have a perfect conclusion that other than inheritance, there is less possibility to use the concepts to provide an efficient vehicle management system, because inheritance makes sure that there is no duplications and provides easy organization methods, and also it creates objects mainly where we can make the code reusable, so we can reduce redundancy and repetition of codes. So this is the best concept to provide and implement the vehicle management system code. So this is the conclusion of the case study overall.
Thank you for the day. We will see you in the next video.
Thank you.
Thank you.